All right, episode 1 of real world applications. In this episode, we're going to be taking the volume of sucrose or granulated sugar and melting it and finding the change in volume and the phase change between solid and liquid.
So we have our granulated sugar or sucrose, which we're going to put into this cup, half cup, 118 milliliters to be precise. So I'm going to fill that up now. All right, so we have our half cup. I'm gonna put it into this tray, which we're gonna put into the oven. All right, so we have our half cup of sucrose. I'm gonna put it into the oven at 375 degrees. The melting point for sucrose is 368 degrees. 375. Start it up. Throw the sucrose in. Now we wait.
We cranked up the heat so that sugar would melt faster.
The outer edges have started melting.
30 minutes since the initial melting point.
It's almost fully melted. Time to see the final product. Oh yeah, that's a liquid, all right.
All right, we're gonna measure the height of the liquid so we can determine the volume of it. Looks to be about 0.7, 0.6.
Now that we've found the actual volume, we're going to calculate our theoretical volume and compare the two. So up here we have our givens, critical pressure and critical temperature for sucrose, and our initial pressure and temperature of our initial pressure was atmosphere and room temperature 294 Kelvin. We also have our molar ratio of sucrose up here. For our initial conditions, we had a height of 0.8 centimeters and a volume of 9.7 times 10 to the negative 4th meters cubed. To calculate, we found our reduced temperature and reduced pressure to find our compressibility value. And over here we have unit conversions to find the total mass in the tray of sucrose. We have 146 grams divided by our molar ratio, which gives us 0.43 moles present in the aluminum tray. We use this equation right here to calculate this final volume using these values, 0.43 moles, compressibility value, our R value, and the temperature of the oven in Kelvin. Over here, we did the math, found it to be 2.646 times 10 to the negative 4th meters cubed, which is greater or less than our initial volume, and it's about 2 times the actual volume we calculated from the ruler in the tray of sucrose, which the height was 0.7 centimeters, and then we measured the volume to be 8.52 times 10 to the negative 5th meters cubed.
So during our experiment, we had some error. There was a pretty significant difference between our theoretical and our actual values. It came out to be 102% error, which really just means that the theoretical value was double our actual value. And we have some reasons for that. One of them is the packing factor. So whenever we found the initial volume in solid form, that there's was some air in between the grains of the solid sugar. So the volume that we measured was probably larger than it actually was if it were to be packed together into one solid form. There was a temperature difference, so the oven was not set exactly at the melting point for the entire time, and the resolution error of the ruler is only so accurate, and our eyes can only read it so accurately. The ruler only goes down to millimeters, so we can't get that accurate of a solution, but